Okay, so we're going to start Chapter 8. Chapter 8 really starts second semester, where we're going to work on inferential statistics. Inferential statistics is the process of drawing conclusions about a population based on data from a sample of that population. So a lot of times we've been working with something that's not necessarily a sample, and we're actually working with the whole population, but now we're going to look more at sampling. So remember, if anything comes from a sample, those are called statistics. So that's like X bar, S, sample median. Those are all statistics. Anything that's a parameter that comes from the whole population, that's like mu, which is the mean, and sigma, which is the standard deviation. So we use statistics to estimate the parameters. So statistics are sometimes also called estimates. The problem with using statistics to estimate parameters is that our estimates usually aren't correct. For example, suppose we know the mean weight of all students at Salem High School is 135 pounds. So mu is 135. However, if we take a random sample of 50 students, we could get X bar, which is the sample, is 160 pounds. So the question then becomes, is that a good estimate? Since the value of the statistic or the estimate depends on the sample, the value of the statistic will vary from sample to sample. So this is called sampling variability. I kind of touched on it in first semester a little bit, but sampling variability is different from the variability we studied so far. It's basically how much the sample varies. So if X is the weight of the Salem High School student, then X has variability because different students have different weights. That's not sampling variability. If X bar is the average weight of a sample of 50 students, then X bar also has variability. Different samples will produce different averages. This is sampling variability, where your samples vary. So thus the statistics or the estimates are variable, while the parameters are constant. So the distribution of a statistic is called its sampling distribution. So we're going to look at sampling distributions in Chapter 8. It's the distribution of all the values of the statistic based on all possible samples of the sample size. So the sample size can change, but the sampling distribution, there'll be one for each kind of sample size. So important features of a sampling distribution, kind of like every other distribution, is shape, center, and spread. So just like SOX in Chapter 3 and 4. But we just don't look at outliers because technically there really shouldn't be any outliers. So suppose our class is a population and we're taking a sample of size 3 to estimate the true average height. So mu. So X is the height. X bar is the average height of 3 students. Let's just take 4 students. So 1 is 68 inches, 67 inches, 72 inches, and 65 inches. Because obviously if I used all 36, there'd be some issues. So the sampling distribution X bar lists all possible values of X bar and how frequently they occur. So you could have your sample. So if I'm just looking at 4 people and I want a sample of 3, I could take 68, 67, 72. I could take 68, 72, 65. I could take 68, 67, 65, or 67, 72, 65. So those are my 4 different samples because I have 4 different numbers. Now let's find the average. So let's find X bar for each. So for 68, 67, 72, I get an average of 69 inches. 68, 72, 65, I get an average of 68.3 repeating. 68, 67, 65, I get an average of 66.6 repeating. And 67, 72, 65, I get an average of 68. So then, how frequently they occur, the probability of each X bar ends up being the same. It's a fourth, a fourth, a fourth, a fourth, because each one's the same probability of happening. So now let's look at a different distribution. So now I have a probability distribution here where each value is independent of the next. So the probability I get a 1, a 2, or a 4. So let's list all the different samples of size 2 with replacement and then calculate the mean of each. So you have your sample, and then you have X bar. So I could pick, so we're doing with replacement, so I can pick the same number twice. So I can pick 1, 1, 1, 2, 1, 4, 2, 1, 2, 2, 2, 4, 4, 1, 4, 2, and 4, 4. So then the mean of each, that would be 1, 1.5, 2.5, 1.5, 2, 3, 2.5 again, 3, 4. So each sample with replacement, each mean. Part B, we're going to find the probability that each mean will occur and construct a sampling distribution of the sample means. So we're going to start looking at sampling distribution of the sample means. We're really going to focus on that in the rest of Chapter 8. Today's just kind of like an intro. So now our table is going to look like this. We're going to have X bar, probability of X bar. So here, all the different options for X bar, I have 1, 1.5, 2, 2.5, 3, there's no 3.5, and 4. Now each probability doesn't occur the same like before because the probability distribution at the top is different. So for 1, that only worked when I picked 1 and 1. So I'm going to do 0.2 times 0.2, which gives me 0.04. So that's the probability that that would happen. 1.5 worked when I got 1 and 2 or 2 and 1. So 0.2, 0.3, 0.3, 0.2. Because it worked when I got 2, 1, and 1, 2. So this would be 0.06, 0.06, so 0.12. 2 only worked when I got 2 and 2. So that's 0.3 times 0.3, so 0.09. 2.5 came up when I had 1 and 4. So 0.2 times 0.5 plus 0.5 times 0.2. So that's 0.20. Put a box on this. 3 showed up only when I picked 2 and 4, 4 and 2. So 0.3, 0.5 plus 0.5, 0.3. So 0.15, 0.15, so 0.30. And 4 only shows up when I do 4 and 4. So 0.5, 0.5. So I get 0.25. So if I want to find the expected value of my probability distribution here, I can do what we did first semester, Chapter 7. So I'm going to do 1 times 0.04 plus 1.5 times 0.12, keep going, 4 times 0.25. And you can still use your calculator. Remember, do list 1, list 2. And you should end up with 2.8. So that should be my average expected mean, which is kind of true because it's kind of in the middle between 1 and 4. Okay, so this is just an intro, just looking at all the different samples that we can take, what their probabilities look like. So if there's each one showing up has the same amount, then it's just 1/4, 1/4, 1/4. But if you have a probability distribution like up here, then you have to calculate it.